Okay, so there we go. Meeting is now recorded and live here. So without further ado, let's go ahead and get started. We have a lot of exciting things to talk about today, so let me go ahead. I will share my screen here, and we can dive right in. So let's see. Hello everyone. Welcome back to the JuliaHealth monthly meeting. Today is August 29th. It has been some time since we had our last JuliaHealth meeting. This is our first JuliaHealth meeting since JuliaCon 2024, which is pretty exciting just because it has been a while. So I'm excited to get caught up with everyone, hear what everyone's been up to, and just dive into more things from there. So I want to take a moment, as always, to go ahead and pause here. If there's anyone new to the call today and want to introduce themselves, you're more than welcome to. No pressure if you do not. Just want to stay silent in the background. But I'll pause here if anyone wants to introduce themselves.
Am I audible?
Hey there.
Hello. So I am, I am new to this Julia Health thing. I just recently interacted with Jacob uh, for the new workspace, work group related blog, and he was kind enough to invite me to this meeting. I will probably also start contributing to the Julia Health blog, more to the front end kind of side. And yeah, I think Jacob will also help me learn Julia a little bit more. About myself, hi, I am Hitad Shah. I have been contributing to open source for quite some time. Uh, if someone might know, I did my GSoC with Julia in Documenter.jl, the new search interface you might be seeing in the latest Documenter version was developed by me, and of course with the help of the community. I was not. I don't want to take the credit, but yeah. Other than that, I have also contributed to many open source projects. I love open source. Because I have learned everything from the open source itself. That is why I am very excited to give back to the open source community, however I can. And if I talk about my professional background, I have been working in the software industry since 3 years. Right now, I am also a software developer. I work on full stack kind of things, both front end and back end. I'm language agnostic, so I like to learn many languages. It's not like I got a special language or something. So yeah, that will be my introduction. If anyone has any questions, feel free to ask.
Awesome. So great to have you. And thank you so much again. Yeah, just as you were mentioning your contributions to Documenter.jl. I mean, speaking for myself, I use Documenter all the time. So just the fact that you're the person who made like major improvements to the search and just how everything works within Documenter, huge thank you for all your contributions and work there. And it's exciting to see around the community. So excited to have you here.
Thank you. I hope to make other major contributions too. So yeah,
Exciting. Yeah, and
thanks.
if there's anyone else who wants to share, I'll let you share.
Hi. So I'm Amanda. Jacob and I met at JuliaCon this year. It was a little bit random, and at some point we started talking, and I said, I use KomaMRI a lot, and he told me about JuliaHealth, and was also very kind to introduce me and help me put the meetings on Google Calendar. Yeah. Yeah, so I'm finishing my PhD in physics. My background's in physics, and I started like my Julia journey with KomaMRI because I wanted something to simulate MRI that was fast and efficient and I found KomaMRI, and I already wanted to learn Julia, so it was like the perfect match. And yes, so I'm very excited to be part of the this, to be part of these meetings and get in contact with all of you and see what's going on. Also, Carlos, and yeah, it's excited to be here. And thank you, Jacob, again for introducing me to the Julia Health community.
Of course, no, it's so great to have you. And I wanted to ask, by the way, when are you finishing your PhD? Is it this year or next year?
No, it has to be until the end of this year. So
Okay.
somewhere between now and the 31st of December. Yeah.
Oh man, so exciting. And
Yes.
yeah, and
Good luck.
also fun
Thank
fact.
you.
Oh, absolutely. And
Yeah.
fun fact
Yeah.
about Amanda, everyone, just so you know, just a fun fact is Amanda can speak like I think we counted Amanda and it was like 4 or 5 actual speaking languages you can also speak. So just a fun fact about Amanda. But it's super great to have you. So
Yeah,
yeah.
it was nice to meet someone who was also interested in Arabic. That was
Yeah.
fun. Yeah. Yeah. Okay.
Okay, is there anyone else who is new?
Me, maybe.
Yeah, go for it.
I don't know if you can see me. I'm on my phone. It's a bit complicated. I have to catch a train, so it's kind of a hustle to get into the meeting, but I'm there. I am Oscar. I work on statistics mostly. I've done a lot of stuff around finance during my PhD, but now I'm a full-time researcher, and I have landed in a lab that is a medical lab, and I'm doing survival analysis and stuff. And there was a message on Slack today about one of my intern actually graduating today, and she did, which is great. And we did code some stuff about a piece of survival analysis that is a bit tailored to cancer registries and data that are very peculiar and specific to medical applications, which is why we're here. Maybe in a few meetings, if she wants, she'll have the chance to discuss that a bit more.
Amazing. And Oscar, great to have you. It was great both to meet you as well as your intern. If I remember her name, was it Reem? Is that how you
Yeah,
pronounce
it's Rim.
it? Reem. Okay.
Yeah.
Yeah, so just, a huge shout out, especially to Oscar and Reem, because if everyone goes to the Slack Julia Health channel and Health and Medicine, you'll see that Oscar shared a nice new message about this new package called netsurvival.jl, as well as an associated paper that just came out. So super, super exciting. Huge congratulations to both Reem and Oscar. And yeah, Oscar, let's chat more later. But with that being said,
Yeah.
just for sake of time, let's move on to some more of the Julia Health agenda topics, as we have a lot to talk about today. So let me go ahead, jump over to the monthly contributor roundup. So unfortunately, this month, I could not find any new Julia Health contributors that I was aware of to the Julia Health ecosystem. I was also having a pretty busy month, so if I missed anyone who was new to contributing around to any Julia Health packages, I apologize. Please let me know if you did, and I will add you to this slide next month. It would be great to see more people contributing. So just let me know if I accidentally missed you. I feel terrible if I did, but we can fix that next month. So moving on to Julia Health news, just some topics that I wanted to share and talk about is that Google Summer of Code is wrapping up. As I think we talked about in a meeting or two ago, we had a new record for number of Google Summer of Code fellows for the Julia Health community. I think we had a total of about 5 fellows for the Julia Health community, which is super exciting, working on anywhere from I think it was like GPU accelerated medical imaging all the way to census microdata. we just had a ton of new contributors as well as fellows for the JuliaHealth ecosystem, which was so exciting to have happen. But if you are a JuliaHealth mentor or fellow, just as a reminder, many of the medium and large project deadlines are very, very soon. I think actually most of them are either due this week or next week as the default schedule. So if you are a fellow working on a project, just be aware with you and your mentors that you'll have to have your final reports written up. You'll have to have reviews coming in both from the mentor as well as the mentee side. And if you do or are in need of any extensions for your projects, just wearing my Julia Summer of Code administrator hat for a moment, please let myself or Avik Sangupta know, and we can make sure that those extension requests get fulfilled as soon as possible. So that way, you all will have time to finish your projects, and there is no concerns about falling behind. So please, just as a reminder, just wanted to highlight that. But we'll come back to some more exciting news about Google Summer of Code in a few minutes here. But before we do, I wanted to take a second to announce that this is, as you can see by the question mark, it's still in flux. But myself and Krishna Bogankar, we are planning tentatively a JuliaHealth fall hackathon. This is basically where we're planning to take a day in October, potentially around like October 6th or October 7th, and just taking that whole entire day to hack on a variety of JuliaHealth ideas and projects, ranging anywhere from just fixing up some of the JuliaHealth issues that we see around various packages, improving documentation, or even spearheading some new research agenda topics that we could potentially work on and collaborate as a community. So if that is of interest to you, please get in touch with me over the JuliaHealth Slack or the Health Medicine Slack channel, or Krishna as well. He's just Krishna Bogankar over on the Slack. So please, feel free to reach out. And the tasks that we'll be working on, that is still kind of up in the air right now. As I mentioned, it could be anywhere from just very basic sort of administrative documentation all the way up to developing some maybe new research collaborations and ideas. So if you are interested, please share your ideas. We'd love to hear them. So with that being said, we will pause here for a moment, and I'm actually going to stop sharing my screen. So let me jump over to the Zoom call here. I have some really exciting news that we had a kind of last minute agenda shift because today, one of our Google Summer of Code fellows, Ryan, who worked with Carlos, member of the KomaMRI team, and really the core developer of the KomaMRI project, Carlos has been mentoring Ryan over the last couple months here for Google Summer of Code. And today, Ryan is actually going to share a little bit about his fellowship project, how that went. And yeah, so at this point, Carlos and Ryan, I will turn it over to both of you. Ryan, I will also give you sharing permissions so you can share your screen soon. Carlos and Ryan, I will turn it over to both of you. Both of you should be able to share your screen if you need it.
Okay. Can you all see my screen or?
Yes, I can see it.
Okay, perfect. Yeah, so I'm here to talk about my Google Summer of Code project, which wrapped up last week. So it was,
And Ryan, just to jump in just for a quick second, you might, in case I didn't do a good introduction about yourself, you might want to give maybe a recap for people who might not know who you are.
oh yeah, so I'm currently a master's student studying computer science at University of Wisconsin-Madison, and I'll be graduating in a few months. But yeah, I've used Julia for like a couple years now, so I was really excited to be able to work on this project and learn more about like different Julia packages for like high performance computing and like GPU acceleration and that all that sort of stuff. And yeah, so I guess just get started talking about what my project was. So KomaMRI, like for those not familiar, it's basically a library for like fast MRI simulation, which like before this project, it already had built-in support for like GPU and CPU parallelization. But as part of this project, we wanted to extend the GPU support a bit more so that it also worked for uh, like it already worked for CUDA, but we also wanted to extend it to Metal, one API, which is Intel, and then AMD as well. And then we also wanted to create a CI pipeline for testing the different GPU backends, and then move from like inside the simulation, move from like array-based GPU parallelization to more like explicit GPU kernels, which should hopefully run a bit faster. So the first step is making it work for different backends. So the operations within KomaMRI are already like GPU agnostic. So the like different array types that are being operated on, we basically just need a function to convert all of the arrays from normal arrays to like CUDA arrays or metal arrays or whatever the corresponding device array type is for the backend. And so this is what our GPU function looks like. So fmap is a recursive function from functors, the package functors.jl, which can like recursively go through like all of the fields of a struct. And even if it's like a struct of structs, recursively call fmap on like each of the fields to convert all of the fields to the like correct GPU type that we want. And then adapt is a function from adapt.jl, which actually does the conversion work. And then backend is a type from kernel abstractions.jl, which is extended by like CUDA and exported. So that this is like CUDA backend, metal backend, etc. And this is really like all that was needed to like make the GPU function work, to like just call it in all of our simulation structs, and it'll automatically go through all of them and convert all of the arrays to the GPU array type that we want, which was it was good that this didn't require like too many code changes. And the like one of the keys to this is that the backend packages like CUDA and Metal, they already define like adapt storage functions, which adapt calls like to convert the like different array types to the corresponding type for CUDA or Metal or whatever. So we didn't need to like do like any like duplicative work defining that ourselves, which was good. And then the next step was setting up a CI for automated testing across different backends. And so we used BuildKite, which is a similar like CI platform that a lot of other Julia packages use. And we decided that in addition to like automated testing across different backends, we also wanted automated benchmarking. So like each time we like submit a pull request or something, we can run some benchmarks and see if it's like if the benchmarks are faster or slower with the pull request changes. And then also have like some sort of like website where we can display the different benchmark results. And so the package that we kind of like took inspiration from was lux.jl, because they had a very nice benchmark page, and they were using GitHub Action benchmark, which it's a popular like GitHub benchmarking tool that integrates well with Julia. And so we decided to use that as well. And then it was a little bit difficult to like get the results from BuildKite back like into the GitHub action. But there was like an existing tool that I found that like did exactly what we wanted, where it can wait for it can identify the corresponding like BuildKite build for a specific commit, and then wait for it to finish and then download all the results. And so after that, after that, we had like an initial benchmarking website, and I can just show what it looks like now. So that this is like GitHub Action benchmark that we're using. It already provides some like default HTML, but one other thing we did is we also extended it to, like, in addition to time, also show like total memory usage and allocations as well, since it's also like useful information to track, and it was already there like in the JSON file that this is like pulling its data from. It was just in an extras field instead of the main field, so it wasn't too hard to extend the HTML to show these other two options. Yeah, and then the next step after that was like before optimizing the GPU part of it, we decided to look a bit deeper at the CPU code and see if we can optimize that as well. And so, like, for optimizing the CPU code, one big thing that we focused on was reducing memory usage. So, like the previous approach, in each simulation block, it would allocate a matrix of the number of time points in the block by the number of spins in the phantom. And we decided it would be a better approach to conserve memory by just using a for loop to step through time. Because unlike with the GPU, we don't necessarily want to like parallelize. You can't necessarily parallelize work when you have like thousands or like millions of threads. So it's a bit more important to focus on conserving memory. And then pre-allocation was also another thing that we made use of a lot. So like from one simulation block to the next, there are a lot of arrays that can be reused instead of like allocating new arrays each time. There is also one expensive calculation for like computing the magnetization at each time point, which we did realize we could skip if it's not added to the signal. And then another thing was there were some statements that like it was surprising that this made a difference, but like if you're like even like if you're multiplying or dividing by a scalar, it's still important to like fully broadcast the statement. Otherwise, the compiler may have some trouble like broadcasting the entire expression. So like there were a few statements that like had a similar form as in our example, and making the change there actually made like a fairly big difference, which was a bit surprising. Another thing was using the sys function for complex exponentiation, which computes the sine and cosine together, and it's a bit faster. Yeah, those are the main things. And after making these changes, we saw a mean speed up of about 4 times and an 80 times decrease in memory usage for the two benchmarks that we were running. And then after that, we were move on to from CPU optimization to GPU optimization. Originally, we thought that like putting everything inside one like big kernel was the way to go to make it run faster. But like one thing we learned was that the GPU broadcasting operations that we were calling were already like quite fast. So like credit to the Julia like GPU compiler team, because like we tried to write some of our own kernels that would outperform operations, and we found that it was like very difficult to actually beat the broadcasting implementation. But there are still like some things that we could do to get it to run faster. So like pre-allocation from one simulation block. So like reusing arrays from in each simulation block, that also helped, similar to the approach with this we took with the CPU optimization. Parallelizing calculations like as much as possible. So like there are some parts within the simulation that need to be done sequentially, but like every part that doesn't need to be done sequentially, if you can like do it all at once, like across all time points, that helps a bit more. And then there are some computations on like small smaller arrays that are faster to do beforehand on the CPU and not the GPU. And then we did write some like actual GPU kernels for certain parts of it. And we found that using the local mem macro and separating the arrays into like different arrays for the real and imaginary components was also helpful for getting it to run a bit faster. And pretty similar to the CPU speed up, we also saw a speed up of about 4 times across each of the 4 GPU backends that we supported, although it did like vary a bit from the one backend to the next. And then the current bottleneck seems to be a kind of weird issue with like logical indexing, which I wasn't able to figure out, but like it seems like there should be a way to get it faster than it is now. So if we can figure this out, then we should be able to speed it up even more in the future. And then the last thing was kind of like a stretch goal. I wanted to see if like we could use the built-in like Julia distributed functionality to run simulations across like multiple GPUs or multiple nodes. And so there were some scripts that I wanted to test whether or not they would work. And if they did, then add them to the documentation. And it turns out they did work, and we didn't even need to make code changes, which was good to see. So the last thing we did was add some examples of like how to run a simulation using multiple GPUs or multiple compute nodes. Yeah, and I think that's it. So yeah, I'd like to thank my mentor Carlos for helping on the project, and then yeah, thank you all for listening.
Wow, incredible work, Ryan. Incredible talk. Thank you so much for sharing. I see all the emoji reactions in the chat right now, so huge, huge congratulations. I saw a number of them throughout your presentation. I don't know if you could see all of them, but wow, incredible work, Ryan. I will open up the floor here for about 5 minutes or so for questions for Ryan, if anyone has any questions or thoughts to share. So maybe I'll go first, Ryan. Like I said, just really impressive everything that you're able to do this summer. I think lots of tremendous work being done. I think a question that I was seeing is when you're talking about some of the issues you're running into, like towards the end with the bottleneck being logical indexing, as well as just everything you're able to do using Julia's native built-in GPU support and just this robust ecosystem around Julia GPU. My question is, have you shared much of this yet with the the Julia GPU team, or engaged much with like the GPU channel here in the Slack? The reason why I ask is I'm wondering if in the future maybe they could help you with like debugging some of those issues, or I'm just thinking of what could be the future next steps with this work.
Yeah, we did ask some like questions in the project in the GPU channel in Slack, and then we also we talked with Tim like a fair number of times, who's like one of the big Julia GPU experts. When we like sometimes ran into issues with like Metal or like one API or one of the other backends. So yeah, I think they're already like sort of familiar with us based on like how many questions we ask them, and we could definitely go to them in the future for like help with yeah, like with the particular issue you mentioned. I think they would be good to talk to get their ideas.
Okay.
Yeah, also Ryan submitted a lot of issues to some GPU packages, and some of them are already resolved. So it was definitely a contribution across packages, not only in KomaMRI.
Oh, that's fantastic. I love that. Just a package or a project that can not only impact JuliaHealth, but just the broader ecosystem is so exciting, and especially coming from Koma is so cool. Okay. Any more questions for Ryan?
It's not a question, but I just want to congratulate Ryan because he did a fantastic job. and you can tell by the results.
Oh yeah.
He even had time to implement the stretch goal that we thought, okay, it would be nice to do, but generally you don't have enough time to do it, and he managed to do it as well.
Okay, if there's no, oh, Amanda, did you have
I
a
think
question?
yeah. First of all, that was really nice. Thank you for the presentation. I wanted to ask if you worked also on like speeding up the sequential arrays. For example, did you also work on speeding up things that you cannot parallelize, basically?
Yeah, so in the GPU optimization, I think the part that we currently have like as a GPU kernel is the sequential part, which I can actually link to it in the chat, but yeah, because we found that the parts that can be done in parallel across time, a lot of those are like can be easily done with broadcasting operations and like one line. But the sequential part is kind of like a lot of steps and it's more complicated. So we found that writing an actual like GPU kernel in that case was beneficial.
Yeah, that's awesome because it's something I have a problem with. So you said you could, yeah, if you could share it on the link on the chat, that would be great. Thank
Yeah.
you. Yeah, that's very interesting. Thank you.
Yeah.
Also, all of this will be available in Koma 0.9 that we will register soon.
That's great. I love Koma. I use it every day. So good to know. Yeah.
Amazing.
Okay. I have one last small question, and then we can move on to some other topics here today. But one last small question from me for I think just broadly the KomaMRI team is, you were mentioning like a performance speed up, just for talking about speed, like a 4 times speed up, and then memory allocation reduction by like you said 80 times roughly about, which is just very amazing numbers. So I'm just kind of curious, like for the KomaMRI team, what would that mean broadly speaking for KomaMRI? To me, it seems like that could make it much more feasible for maybe not as for lack of a better term, maybe like high-end machinery or computers to be able to actually work with Koma and run it like locally. I'm thinking like in terms of like, maybe school settings, like, for students who might want to use this in a course or something like that. It seems like this has the effect of enabling a lot more users of Koma. Is that like an idea, or I'd be kind of curious to see what this means for the Koma team in general.
Yeah, so the fact that stuff takes, I don't know, 2 seconds instead of 1 minute is like a game changer for a lot of stuff. One of them could be like, as you say, education, because people do not have the beefiest computer. And now, well, we previously only supported CUDA, so only NVIDIA GPUs, but a lot of students do not have like computer with an NVIDIA GPU. They have a MacBook that has an M1 chip, and now they also have the same speed ups, like, or comparable speed ups. And the other thing, more in the research side, is that now you can simulate larger stuff, like more complicated scenarios. Like flowing blood inside some blood vessel, or something that requires like a lot of memory that it was not previously possible before because we were using too much memory, and now it will be possible to do.
Wow. Yeah. All right. Well, thank you, Carlos, and a huge shout out again, Ryan. Fantastic talk, fantastic work. Thank you so much for being able to share today. That was extremely exciting. So with that said, we will move on to the next discussion topic here for today. I think just due to time constraints, this might be the last item we have time for. So let me go ahead, share my screen. We might be able to get to another agenda topic, but we shall see. And that is back over here. Just doing a small kind of debrief on JuliaCon 2024. Just wanted to kind of quickly talk about it before we get too far away from JuliaCon. As I mentioned, this year JuliaCon was in Eindhoven, Netherlands, back in July. And I just want to take some time just kind of, from my side, I was able to attend, and I just wanted to share some of my thoughts. I wanted to hear a little bit from the JuliaHealth community as well about, what thoughts they might have around JuliaCon. But first, just wanted to, say some exciting highlights, which was just, there's so many talks and attendees. This was actually my first JuliaCon abroad over in Europe. So that was really exciting to see. So many people that I haven't seen before. Last year's JuliaCon was in Boston, Massachusetts, in the United States, but this year, like I said, was in Eindhoven, Netherlands. So it was really exciting to see some of our European friends in the Julia world over there. And also at JuliaCon 2024, if you have not heard, the new long-term support release is going to be Julia 1.10. So super exciting to hear that. We're finally moving to a new LTS in the Julia community. I've already started migrating some of my own JuliaHealth packages to 1.10 and dropping support for 1.6, which I am so happy about. We're also moving towards having small binaries that Jeff Bezanson, as well as some of the other Julia Hub team, have been working on. And to quote one of my friends, Kim, she was saying that was kind of her best conference ever, being a mix of, a kind of scientific as well as like hacker type of conference. She thought we hit a really good, mix of the conference in general. So I thought that was really exciting to hear from some folks at JuliaCon. Some lessons that, I learned or I took away from this year's JuliaCon is that there's just so many people doing so many different things. What I mean by that is, there are so many different talks from people doing, especially like things like health research across the Julia space that, I just didn't know about, or, and vice versa. They didn't know we'd existed exactly in JuliaHealth. And, folks, definitely seem to be interested in JuliaHealth. And, some of the questions that I heard is kind of like, where are you? Or, where do you guys meet, or how can I like get involved or learn more? So that was kind of interesting just to hear about, people wanting to be, involved, but just didn't know where to go to get involved. And, another point that, I took away was, talking to some other Julia, or not other Julia, but rather health researchers broadly. I had, the privilege of this year being on a panel for, a diversity, equity, and inclusion event that we're hosting. And I spoke with a lot of people from like the R ecosystem, the Python ecosystem. And, one thing that, one aspect of JuliaHealth that, is still, I would say, in my opinion, still kind of lacking is in the public health research space. And, I heard from so many people just that, R is still kind of the go-to language and tooling ecosystem for, public health research in this field. So I want to open it up for maybe a discussion here just around, kind of a post-mortem, what did you take away from JuliaCon 2024? So these are some of the questions that I put together around JuliaCon 2024. This isn't necessarily like, even if you weren't able to attend JuliaCon this year, if you've attended JuliaCons in the past, or, maybe you participated virtually this year in JuliaCon 2024, I'd love to hear kind of some thoughts around what we could be taking away as a JuliaHealth community. How could we, be involved more within JuliaCon in the future? And so these are just some like questions I threw up about JuliaCon that aren't necessarily related to, like, we don't have to discuss all of them. These are some ideas of what we could discuss. And so I'm going to pause here if anyone would want to, share some initial thoughts, and we can go from there. And if no one jumps in, I can go ahead and take a question, but I'll pause for a moment.
At least for me, I saw some great talks about transitioning from MATLAB to Julia, for example, and all the challenges that has. So, for example, people expect something to work and it doesn't work. And I think those kind of talks and guidance, especially for our field, on how to transition from R or for MATLAB, I think it would be like very important. Because I think all of the tutorials or stuff like that are coming from people that already know how Julia works, not from people that is their first approach to Julia.
No, I think that's a really good point, Carlos. And that's actually a discussion point that I had with one of our panelist speakers. I can't remember for the life of me her name. She's a professor over in the Netherlands, and she works in applied epidemiology. And we were discussing about the fact that, for example, she still uses R quite frequently. But as we got chatting, she's like, I'm a fan of Julia. I like the idea of it. I like what you can do with it and how it can be so much speedier or better in many cases. But she's like, I'm still kind of stuck over here with my R public health tools. And something that I'm kind of excited about is with the JuliaHealth blog getting stood up and other people coming into the JuliaHealth ecosystem, is I think just even having some of these, like you said, Carlos, small tutorials around making this transition from whatever language folks are using into Julia would be great. But I also think showing like how you can be productive by using like the Julia interop tools, such as Python call or R call, or I think it's mat.jl or matlab.jl now for MATLAB, where you can kind of live in the Julia verse, if you will, or the Julia ecosystem, if you will. But then when you need the tools that still just aren't in Julia, you can just use R call to be able to bring your R tools over into the Julia ecosystem. And I think that's something that we just don't have tutorials or demonstrations of just yet. I think that's something as a JuliaHealth community would be great for the future. Might be a great hackathon idea.
Yeah, and I agree with what Carlos said. And we met so many people that said they were moving from MATLAB to Julia, and I think this would be something that would be really helpful for a lot of people. And I just wanted to, for me, it was also one of the best conferences. It was really nice. I learned a lot and met you. I'm here now. And I also went to some mini symposium, and it was really nice. And I thought, like as you suggested here, I think it would be something that would be very interesting to have like a JuliaHealth mini symposium because there's so many different topics that you can talk about. And yeah, so that's a good idea. I think that would be nice.
Ooh. Yeah, I was thinking about that. This year, I knew that there was some JuliaHealth presence this year. We actually had. I'm still trying to figure it out, everyone. So everyone listening in right now, I do have JuliaHealth stickers. I'm trying to figure out how to distribute those, but I think having a more involved presence in JuliaCon in the future would be super duper great. The mini symposium idea I had was, I think we've grown to a point within the JuliaHealth community where I think we do have enough to talk about, a lot for a mini symposium length time, because that could be about. I need to double check the hours, like on average, how long mini symposiums take, and maybe Amanda, you could help me with this. I think mini symposiums might be like 3 or 4 hour blocks, and you just kind of organize those mini symposiums, within like one Julia sub community. And I think that would be awesome to have, like you said, Amanda, like some sort of mini symposium. That would be really nice. And it's also great to hear that you had a great time at the conference as well. I'll pass that along to some of the organizers. I'm sure they'd love to hear it. But maybe, Amanda, you could share more about what you could envision as like a Julia Health mini symposium. I'd love to hear it. I'm sure others would too.
I went to the aerospace one and the quantum mini symposium, and like there were talks from 10 minutes to 30 minutes, and it was very, very applicable, right? So they talk about a package and they did a lot of demonstrations, and that was really nice because even if I'm not from the aerospace community, but I learned so much about toolboxes and things like this. And I think just like health is such a very interesting topic. So you have, I don't know, like KomaMRI, for example, like in the mini symposium, it would be nice. You can simulate, brains and stuff. And this is really interesting. And I don't know, the things you were talking about at the beginning. So I don't know, like I think for something like this, I think it was, like you said, about 4 hours. So not that long. Yeah. Giving, but a few smaller talks. So I don't know.
I just want to say that I would gladly contribute if there's something more organized. This is for next JuliaCon, no? Or
Yeah, and that would be for JuliaCon, and definitely like I'll have to, you're getting me thinking more and more about this, Amanda and Carlos. Just thinking around like, could there be other places? Because waiting for another JuliaCon, that'll be another year. I'm just imagining right now. Could there be other places to do workshops as well, or mini symposia types of things that might not necessarily have to be just every JuliaCon, which could be either here in the Americas or back over in like towards Europe somewhere. I'm just trying to think of how we could do that, but yeah, Carlos, to your point though, this would be for tentatively next JuliaCon next year, next summer.
And if we want to do it, how do you propose a mini symposium? Because I attended JuliaCon, but I just proposed like an abstract. Is there a way to propose a mini symposium? Okay.
Yeah, it's actually very similar to a proposal for an abstract. It's more just now you're pitching not just an abstract for one project. You're kind of pitching a portfolio of projects that could potentially be centrally organized in like a mini symposium format within JuliaCon. So how that would usually go is you'd find some volunteers who'd be the orchestrators of the mini symposium, and then you'd solicit calls for proposals from your mini symposium attendees. So it's almost like my understanding, and I'll research this more, Carlos, is you almost run like a mini conference inside of the bigger JuliaCon conference itself. I think you can even have like different timelines, and I'm sure that gets very tricky. But like I said, the root of it would be that you're pitching this portfolio of projects as opposed to just one project. So maybe, Carlos, you and I don't know, Amanda, if you want to be definitely maybe we should share this more broadly in the health and medicine channel, so anyone can be involved in organizing this. But we can communicate more over the Slack. And Amanda, if you want to be looped in, you can, or we can just share it publicly on the health and medicine channel to figure out what we could do here.
Yeah, that sounds interesting. I'm not really sure if my work it's between optimization and health, so I don't know where that would fit. But yeah, I would be interested in checking out something like this. And like you said, it's kind of like a mini conference inside a conference.
Yeah.
And I know there were some mini symposia that had more slots, and like I think for the quantum one it was 2, and then for the optimization it was 3. So it doesn't necessarily have to be like the same size, all of them.
Yeah.
So, yeah, depending on but yeah, for sure that'll be nice. Yeah.
Okay.
Yeah,
Exciting. I love this. This is exciting. Okay. And I think, just for the last 5 minutes that we have here, we might go over by like a minute or two. So folks, if people need to drop off, they can drop off. I did just want to take a second. I had in mind a longer tutorial for this next topic here. But I did just want to take a second to shift topics here as we're closing to talk about the Quarto JuliaHealth blog that we now have hosted publicly on GitHub, as well as the web. So this is the JuliaHealth blog right now. As you can see, there's not much to it. We're actively soliciting, contributions and blog posts from people. We actually have our first, contributed blog right now from Michaela Rochetti, another Google Summer of Code contributor for JuliaHealth. She worked on a small project related to census microdata. So as you can see here, this is the blog that she wrote, where she's just talking about all the different worksheets that she did, throughout the summer, how the code works, and things of that nature. So right now we're using this JuliaHealth blog as a entry point for people interested in either Google Summer of Code, JuliaHealth in general, or how they might want to be interested in just exploring Julia for health research in the future. So I did just want to take a second just to show very quickly the workflows around Quarto in the JuliaHealth blog before we wrap up for today. So let me go ahead. I'll just very quickly here pull up the JuliaHealth blog GitHub repo. So this is the JuliaHealth GitHub repo. I'll share that into the Zoom chat right now. So here is the repo link. So coming back over here, generally how things will work is if you're interested in contributing a blog post to the JuliaHealth blog, all you'll need to do is create a pull request. I'm going to pick on Jay here, another Google Summer of Code contributor who is currently working on their final blog post for their fellowship. As you can see, Jay's created one file. Generally, how this works is you go into the root of the JuliaHealth blog repository, you go to posts, you create a new folder, and then within this new folder, or within this post folder, you create a new folder, and then you add a file called, it could be index.qmd, or it could be myfile.qmd. And if you want a reference when you're writing your blog or blog post, look at the dummy folder, as this contains a dummy blog post that you can reference for creating your own blog posts. And then you write your blog in basically a specific flavor of Markdown called Quarto Markdown. You can just copy and paste this header content here, and then you can start writing your blog. One thing that I wanted to share is that VS Code actually has a Quarto extension. So this is, I have VS Code shown here. You can install Quarto, the Quarto extension for Visual Studio Code. You'll need to install Quarto on your computer if you're using Windows. Windows has a really nice installer that you can quickly install on your computer. Macs also have an installer that they can use for Linux. You just need to install the deb or tar package, add it to your path, and once that is added to your path, VS Code in the Quarto extension will be able to automatically detect if Quarto is installed on your computer. And then from there, if you want to preview or look at your blog post as you're writing it, you can write Quarto preview. It'll take a second to update everything. And then as you can see here, you get this kind of generated information from VS Code, and it's running all of the information, running the different Julia blocks shown here. And then you actually get this nice preview within VS Code itself of the blog post that you're writing. So this is actually the blog that you'd be writing if you were to choose something to publish on JuliaHealth blog. So I just want to take a few quick minutes to show this overall workflow. I can give a more in-depth tutorial of this maybe next meeting that we have. But if you are interested in contributing to the JuliaHealth blog, we would love to have you and show more and resources and use cases for health research in Julia. But I know that we are just over time by like a minute, so I want to go ahead and be respectful of everyone's time. So thank you everyone so much for joining today. I hope this was a interesting and insightful meeting for everyone. It was great to have some new faces as well as returning faces coming to this JuliaHealth meeting today. Thank you everyone so much for joining, and be in touch over the Health and Medicine Julia Slack channel. We'd love to have you. So thank you everyone so much for joining this month, and I'll see you all in the next meeting. Bye, everybody.
Bye.
You.
See you.
Bye.